right. So remember, we're going to do PEMDAS in backwards order. So I have to get rid of the fraction 3 over 2 or the 3 because I want p by itself, right? I want it to look like p equals some stuff. So we're solving for p. So the first thing I'm going to do is divide both sides by 3. Okay. 3 divided by 3 is just 1. 1 times this stuff is going to be p raised to the 3 over 2. And then, I don't know what that is, 512 maybe? Let's see on the calculator. So there's some fancy calculators floating around. Grab one real quick and double check this with me. 1536 divided by 3 is 512. Cool. All right, so I don't know why I closed that out. So this is going to be 512. Now, I had an interesting conversation with a student yesterday, and on one of the other examples, I'm going to explain how we get rid of this 3 halves. But I said, in my explanation yesterday, I said, remember that when you take a power and raise it to a power, the exponent shortcut or property is that you multiply the powers, right? You guys remember that? And so I said, in order for me to get rid of this, what I really want to do is make this equal 1. Well, the best way to make a fraction equal 1 is to multiply it by the reciprocal. And then over to the side, I said, all right, this is what this looks like. So then I said, if I apply this property, and I said 3 multiplied, so remember when you do 3 halves times 2 thirds, you just multiply straight across, and that gives you 6 over 6, right? So what's 6 over 6 reduced down to? P to the first power, which is just p. Okay, that's just simple, math. And then I said, whatever you do on one side, you got to do to the other. And that student was stuck right here. They had all of this written down on their paper. They didn't have any of this stuff written down. So they had all of this stuff written down. And he kept saying, well, why is it that you did it this way? And I said, go, let me see your paper. And I said, why didn't you write all of this down? And he said, well, I didn't think that was important. And I said, well, it literally shows why I'm doing it. And so that's another thing that's interesting to me, is that you guys tend to arbitrarily choose what you think is important. And sometimes the stuff that you think isn't important is the most important thing. It's all important. Anyways, this reduces down to p. And then remember that this is the power over the root. So the power, well, the root is 3. So we're going to take the third root of 512 and then raise that to the second power. Okay? All right, so then I need to think of a number raised to the third power that's 512. Well, on my calculator, and it's already there, but we're going to pretend that we don't know what it is. I just say 2 to the third power. Is that 512? No. I say 3 to the third power. Is that 512? No. 4 to the third power. No. 5 to the third power. No. 6 to the third power. Is that 512? No. And I just keep repeating this process until I get to 512 or past 512. 8 to the third power actually equals 512. And it's not that hard. You just go through and plug that stuff into the calculator. Okay? That's it. That's all you got to do. So now that I know that, and another thing I wrote over here to the side, I said 8 to the third power equals 512. So because this student arbitrarily chose not to write all this stuff down, they didn't understand how in the next line that I was going to write the third root of 8 to the third power squared. or 8 squared equals 64. And that's the answer. Does that make sense? All right, I'm gonna zoom out and let you guys write this down. Are there any other questions that you'd like for me to go over today that you could think of?